We are going to work through some applications of solving these quadratic equations, some of which we actually have already done, but it's really good to reiterate these and make sure you really have a solid understanding of it. For our first example, we're determining the x and y intercepts and the vertex of this quadratic function. Now, if I look at this, oh, and then we want to sketch it. If I look at this equation, this is that standard form of the equation, and we had summarized on our summary sheet before this unit even began that the a value tells us the direction and width of opening. So this parabola should be opening down and fairly skinny compared to y equals x squared. And the c value, the +6, tells us the y-intercept. So right away I can state, without doing any work except looking at this, is that the y-intercept is at 6. So 0, 6 when I go to graph that. All right, my x-intercepts I need to get by letting y equal 0. So anytime, no matter what kind of function it is, whether it's a line or a parabola or any other ones that you learn along the way, for the x-intercept, we let y equal 0. So we're going to stick 0 in where the y is, and then we're solving for those x-intercepts, which is really solving this quadratic equation. Now, if I look at this, the first thing I want to do is see, can I common factor this? Unfortunately, no, I can't, except in terms of number parts, or x's, except I do have this negative in front of the 8. I prefer to work with a positive x squared term, so I'm going to actually common factor just -1 out of each of these terms, which in effect just changes the signs of everything when I divide them by -1. All right, so that is 3 terms. It is not a simple trinomial, nor is it a perfect square trinomial. So I'm going to go into my chart of looking for two numbers that are going to add to 13 and multiply to whatever 8 times 6 is. 8 times -6 is -48. So my factors of -48, they're going to have opposite signs to be a negative when they multiply. And my larger number is going to always have the sign of what I'm adding to, so my larger number has to be positive. That means my smaller number is the negative. So we have 1 and 48, and 2, -2 and 24. I think 3 and 16 will work to multiply to 48, and actually as I'm looking through these, there's the one that adds, so I don't even have to go any further. I know that that one will actually add to the positive 13, and because this is a tricky trinomial, we're going to decompose that middle term. So we've got our -3x and our +16x and our -6 here. If I pair up the first two, they have an x in common, so we're going to have negative, and then x bracket 8x minus 3, and then out of the second pair they have a 2 in common, a +2 in common, +2, and I get an 8x minus 3. And you might have paired those differently, but in the end your factors should end up being the same factors as what I have here of 8x minus 3 with an x plus a 2. Those are our factors. The 8x minus 3 was common to both. All right, now we're going to set each one of those little factors equal to 0 and solve for the x-intercepts there. So we're going to get 8x minus 3 equaling 0. Add 3 to both sides. Add 3 to both sides, so 8x equals +3. Divide both sides by 8. X equals 3/8. Ooh, I did not do a fun job on this one. That's okay. These are going to be fun to work with. My other one will be x plus 2 equals 0. Ooh, that's a little easier. That gives me an x-intercept of -2. All right, so my x-intercepts are -2, 0, and 3/8, 0. Now, we need to get the vertex. So remember about parabolas, the thing about the parabolas is that they're symmetrical, which is very helpful. We know our parabola opens down, we know the y-intercept, we now know the x-intercepts. I'm going to actually start to sketch this just so we can see what's happening here. So 3/8 and -2, and we're opening down, and y-intercept is +6. Okay. So here's my x-axis, here's my y-axis, here's my -2. I'll put 3/8 here. This is just a sketch. And we're opening down. So halfway, because a parabola is symmetrical, we know that halfway between those x-intercepts should be the vertex. And here on the y-axis is our y-intercept of 6. So let me just label the points that we know so far. You could take the 3/8 to a decimal if that makes you smile, if that makes you happier. Now, our axis of symmetry, remember, happens exactly halfway between these two x-intercepts. So to get your x-coordinate of the vertex, or the h, the x-coordinate of the vertex, we're going to add those two x-intercepts together and divide by 2. It's the midpoint that we're finding here. Now I just put that in my calculator to calculate it, and I got a negative 0.8125. So that's what this x-coordinate of the vertex is. That's going to be what the x-coordinate is up here. And then the y-coordinate, to get it, we're going to put that value that we just found into our quadratic equation that we were given at the beginning. So where we have the x, we're going to sub in the value of the x for the vertex, and that will solve for our matching y-coordinate of the vertex. So just put that in, and you can just calculate that all in one step in your calculator. Just be careful that you do that correctly, but for sure you can put that in to your calculator in one step. All right, so I've labeled my vertex there. Now, my diagram's definitely not to scale, because clearly the vertex y-coordinate's at 11.28 roughly, and my y-intercept's at 6, and they don't seem like they're far enough apart. But as long as you label your values correctly on a sketch, you're fine with that for communication. If you have a grid, you can do it more accurately, but we'll just go with that for now. All right, write an equation in the standard form, y equals ax squared plus bx plus c, to represent the parabola shown in the graph. Now, vertex form is going to be kind of hard to do because I can't really tell where the y-coordinate of the vertex is. It's slightly above 6, but I don't know exactly where it is. So what I can see is that my x-intercepts are at -5 and at +2. So I'm going to go with my factored form here. So I know that if I have my factors, I can use the r and the s. Doesn't matter that I've put the s before the r. I'm going to sub those values in. I know that I will have an x plus a 5, because it's take away -5, and we'll have an x take away 2. Now to get the a value, we know it should be negative because this parabola is opening down. We're going to sub in this point of 1, 3. So 3 is the y, goes in for the y, and 1 is the x. It goes in where there's an x. And then we just evaluate inside the brackets. So 1 plus 5 is 6. 1 take away 2 is a -1. So we have 3 equaling 6 times -1 is -6, times an a is -6a. To solve for a, I'm going to divide both sides by -6. And when we do, we get a being equal to -0.5, or -0.5. So a equals -0.5, or -0.5. So the equation is, in its factored form, will be y equals -1/2 x plus 5 and an x minus 2. Now, that's not our standard form, but we know from our summary sheet that we did at the beginning of the unit, we could expand and simplify this to put it in its standard form. So let's go ahead and do that. You're going to hop through that bracket, multiply through. We're going to get an x squared minus 2x. And then we're going to have a plus 5 multiplying the x and the minus 2, so plus 5x minus 10. And then multiply everything by a -0.5. We're going to get -0.5 x squared. We're going to have a plus x. A half of -2 is, a -0.5 of -2 is just 1. And then minus 5/2 x. It might have been easier actually to combine these two things first. I think that's what I will do here. Combine those two things first. I have the beauty of being able to erase things. Let's combine those. That will be a plus 3x and a minus 10. And then I'm going to hop through that bracket, and we're going to get minus 1/2 x squared minus 3/2 x plus 5. So there we are with our equation in its standard form.